our next lesson is about volume and density. And in this lesson, we'll hit one CCRSM standard to apply concepts of density based on area and volume in modeling situations. We'll also talk about the definition of volume and some properties about volume. Let's get started. Today we're on lesson 8, and I want to start off by giving you the definition of volume. Now, it'll be very similar to our definition of area, which, let me remind you, is the number of 1 unit by 1 unit squares that fill a two-dimensional object. Well, volume is similar, except now we're filling a three-dimensional object. But we can't fill it with squares, we'll fill it with cubes. So the definition of volume is the number of 1 unit by 1 unit by 1 unit cubes that fill a three-dimensional object. And so if we give a volume of 8 or a volume of 10, that means there are 8 or 10 1 unit by 1 unit by 1 unit cubes, or let's say 1 cubic centimeter, 1 cubic inch, that fills that object. Okay, that's the definition of volume. Now, to give you a basic understanding of the properties of volume, I want to go way back to multiplication. Okay, when we say 3 times 5, I know that you know the answer is 15. Okay, but what that means is I want 5 groups where each one is 3. So if I take 5 groups of size 3, that's 15 dots because I have 5 groups of size 3. Okay, that's very similar to how we found the area of a rectangle or a parallelogram as base times height, because we have h groups of size base. Let me give you an example of that. Down here, if I think about this as the rectangle, we'll cut it into a triangle later, but right now just the rectangle. If I think of this as h number of size the same length as the base, that's why I have multiplication when finding area. Okay? Now, the reason that the triangle is 1/2 of that is because I take that area and cut it in half to find the area of the triangle. So it's half of that number of groups. Okay, so with that foundation of multiplication and counting number of groups, I now want to move to talking about volume. On the left, there's an image that you do not have in your student materials. I found it online, but I liked the image and how it shows what the volume is. Now, Engage New York uses capital A times H. The most common things I see is that the volume is equal to capital B times H, but whether you call it H or B, it's the same idea. So let me go through this. The volume of the cylinder, and we'll talk more about cylinders in a future lesson, but the volume of the cylinder is the number of 1 unit by 1 unit by 1 unit cubes that fill that space. But the way I think that through is I think about capital B, the area of the base. Then in the base, I have B number of 1 unit by 1 unit by 1 unit cubes that fill the base, and I have H number of layers of that size. So using multiplication, because I have H groups where each group is size B, and that's why I have multiplication for the volume of a solid where capital B is the area of the base. That can also be seen over here with this triangular prism, because A is the base and H is the height. And so if I think about having a layer of 1 unit thick, I will have A of those, and then with a height of H, I have H layers. And so the volume of the triangular prism will also be, in this case, capital A times H, because the area of the base was A. Next, we'll move to density. And density is what actually aligns with our CCRSM standard for this topic. So be aware that we'll be using a lot of density. Now I'm hoping that in your science class, or science classes, you've learned about density. The fact that density is a measure of the mass divided by volume. So an example of things with high density are things that are small and hard and heavy. And examples of things with low density are things that are big and light. Okay, so that's an idea of density as the measure of the mass divided by the volume. Now, number 3, we're given a question about a square metal plate. And we're given the density of 10.2 grams per cubic centimeter. And it weighs, that's the mass, it weighs 2.193 kilograms. Now, using this formula, I know that the density is equal to mass divided by volume. And they've given me the density of 10.2 grams per cubic centimeter. Now they give me the mass in as 2.193 kilograms, but hopefully you've learned in science that your units must agree. They must be the same units. And I have grams and I have kilograms, and so it's much easier if you work within the same unit. Now I'm hoping that you know that 1 kilogram is equal to 1,000 grams. So that means if I have 2.193 kilograms, then I have 2,193 grams. So that's what it is in terms of grams, and I'll use grams so that I keep all with the same unit. So the mass in grams is 2,193 grams divided by the volume, and we don't know what the volume is yet. Okay, to solve this, I am going to use some algebra, multiply both sides by the volume to get the volume out of the denominator, and then I will divide by 10.2 grams per cubic centimeter, and then divide both sides to keep it equal, grams per cubic centimeter. And this will cancel with this, and the grams will cancel with grams, and the cubic centimeter here in the denominator of the denominator is the same as putting it in the numerator. So the units I get are cubic centimeter. But how many cubic centimeters? Well, I take 2,193 and divide by 10.2, and I get 215 cubic centimeters. That means there are 215 1 centimeter by 1 centimeter by 1 centimeter cubes that fill this square metal plate. Okay, the next question is if the base of this plate has an area of 25 square centimeters, so here's the base, 25 square centimeters, and it's a metal plate, it's three-dimensional, determine its thickness. Well, the area of 25 square centimeters means there's 25 1 centimeter by 1 centimeter squares that fills the base of that plate. And there's 215 cubic centimeters that fill the entire volume. So if I go back to the equation of volume equals the area of the base times the height, if the volume of the metal plate is 215 cubic centimeters, and the area of the base is 25 square centimeters times the height, then I can do some algebra to solve for the height and divide both sides by 25 square centimeters. And this cancels with this, which leaves me with just the height. And over here, 215 divided by 25 is 8.6. And then with the units, then 2 of these centimeters cancel with 2 of these, and I'm left with 8.6 centimeters, which means there's 8.6 layers of 25 cubic centimeters, or that the height of, the thickness of that plate is 8.6 centimeters. And that's it. This lesson is about volume and density and the definition of volume, which is the number of 1 unit by 1 unit by 1 unit cubes that fill a three-dimensional object, and some properties of volume. Thank you for watching.